Presenting my geotechnical assessment of the proposed dam and reservoir located in the Gamatipa-Ragopola area in Limpopo province. The aim of this project was to evaluate whether the site is suitable for the construction of a dam and reservoir using available desktop information. No field investigations were carried out, so the assessment is based on topographic data, geological maps, satellite imagery, climatic information, and engineering judgment. The proposed dam is intended to provide a reliable water supply to surrounding rural communities and support small-scale irrigation. Because this is a desktop study, the investigation identifies potential geotechnical conditions and risks that would need to be confirmed during a detailed site investigation before construction begins. The site is located within a predominantly rural area of Limpopo. The proposed dam wall is positioned on moderate natural slopes, which are suitable for an embankment dam, while the reservoir basin is relatively flat with only a gentle gradient. This flatter basin is beneficial because it allows efficient water storage with reduced earthworks compared to a steep valley. The regional geology consists of rock belonging to the Bushveld igneous complex, mainly gabbro, norite, and pyroxenite. The expected ground profile consists of topsoil extending to approximately half a meter, followed by residual soils about 2 meters, then saprolite down to around 8 meters, and finally competent bedrock below this depth. The residual soils are mainly clay gravels and sandy clays, which generally have low to moderate permeability. However, localized seepage may occur through weathered zones and fractured rock, making seepage control an important design consideration. The main geotechnical risks identified are variable soil conditions, differential settlement, seepage, and geological discontinuities. The nearby Steelpoort fault and associated jointing may provide preferential seepage pathways if they intersect the dam foundation. These geological features reduce the uniformity of the foundation and therefore require detailed investigation before final design. To reduce these risks, the dam should incorporate a compacted clay core together with a properly designed cut-off trench extending into competent low permeability material. Since this was a desktop assessment, I proposed a comprehensive field investigation program. This would include boreholes along the dam axis and reservoir basin, together with the trial pits to confirm soil conditions. Laboratory testing should include uniaxial compressive strength tests, triaxial compression tests, direct shear box testing, tensile strength testing, durability testing, as well as soil shear strength and consolidation tests. These investigations would provide the engineering parameters required for safe foundation and embankment design. Construction of a dam has significant environmental impacts, including habitat loss, altered river flow, downstream erosion, and sedimentation. Therefore, environmental impact assessments, together with compliance with the National Environmental Management Act and the National Water Act, are essential before construction. In conclusion, the site appears to be technically feasible for the proposed development. The competent Bushveld bedrock provides an excellent long-term foundation. However, because of the variable weathered soils, jointed rock mass, and the nearby Steelpoort fault, a detailed geotechnical investigation is essential before any final design is completed. Provided that appropriate seepage control measures, including a clay core, cut-off trench, and if necessary, a clay liner or geomembrane are incorporated into the design, the proposed dam can be developed safely and effectively. Thank you.